Hello, this is Mrs. Pullen for Algebra 2. In this video, I'm going to go over the Unit 2 review sheet, problems numbers 21 through 24, which focus on transformations of functions. So we're given two different parents, f of x equals x squared, that's a quadratic. That's the quadratic parent, and g of x is equal to square root of x, and that parent is the square root function. And we're going to transform it. So the transformations can be recognized in a certain form. So A is going to represent like a reflection. It's also going to reflect vertical stretches and compressions. What's inside the parentheses represents the horizontal transformations. Specifically, if I'm adding or subtracting h units, that represents movement to the left and right. When inside parentheses you have a positive number, you're moving to the left. So if it was x plus something, you're moving to the left, and if it's negative, you're moving to the right. Likewise, the k on the outside of it, so this represents horizontal. Let me write horizontal. And over here represents vertical movement. And if it's a positive k, if this is a positive value, so positive you're going up, and negative you're going down. Similarly, you have the same thing with the g of x function. Inside the parentheses represents horizontal motion. If it was plus h, you're going to the left. And if it was like a negative h, you're going to the right. Positive k, the following is vertical motion, so this is vertical. If it's a positive constant, you're going up, and if it's negative, you're going down. So for the horizontal, it's the opposite of what you would expect. Okay, so now let's take a look at h of x. We see something squared minus 5, so we know that the parent was f of x. So what's happening to this function? Since you have a positive 2, you're moving left 2 units and down 5. In function notation, h of x could be represented as, since the parent is f, it would be f of x plus 2 minus 5. That's how you would write it in function notation. And then last year you should have seen the translation notation. So you're moving 2 units to the left and down 5 units. Okay, next let's look at h of x. So now we see that the parent function is g of x. Inside the parenthesis represents the horizontal movement. Since it's negative 7, we know it's opposite of what we think. It's going to go right 7 units and up 3 units. In function notation, h of x, now we're dealing with the parent of g of x. So it would be g of x minus 7 plus 3. So you're taking g and you're moving it right 7 units and up 3. In the notation from last year, it would be negative 7. That represents the x-coordinate, and you're moving 7 spaces to the right, so it should be plus 7, forgive me, since you're moving to the right, and 3 units up. Let me just make that more clear. It's positive 7. Okay, h of x is a little different. It definitely is with the quadratic because we see something squared, but we notice we have a negative outside the parenthesis. When that occurs, what's happening is you're reflecting over the x-axis. So when it's outside the function, it means that you're reflecting over the x-axis. Then what's happening? You're moving, notice it's something in the parentheses is 24. If it's inside the parentheses, it affects the horizontal, and you're moving right, since it's negative, 24 units. The positive 19 on the outside, that's not inside the parenthesis, means that you're moving 19 up. In function notation, it's h of x is equal, again, it's f of x this time, since you're affecting, since the parent is the x squared. You're reflecting, so there's a negative outside the function. Negative, if the negative is outside, you're reflecting over the x-axis. You're moving right 24 units and up 19 units. This is more than just a translation. The first thing you're doing is you're reflecting over the x-axis, if you were using the notation from last year, because that negative is outside that function. And then you're translating 24, you're moving right 24 units and up 19. So that's why you have a positive 24. Okay, last one I starred, the reason why is this is a little bit more challenging, and the reason why is you have to follow a specific order when you're doing transformations. Reflections always come first, then horizontal movement, and then after the horizontal movement, then the vertical motion. Or vertical movement. Okay. But if you look at these functions, they have to be in specific form. So like if I'm looking at h of x, it has to be a square root, and then it has to be, there's something that could be on the outside, like it can be outside the parenthesis, but it has to be in this format. So the x has to be by itself. And you see how the x is negative here? Before we can figure out the movement by just looking at the function, we have to factor out that negative x. So it's equal to the square root of negative x minus h, and then, so x minus 6, sorry about that, minus 8. So when the negative is under the radical, that's like the input into the function, what happens is you're reflecting, but you're reflecting horizontally. So reflect over y-axis, then you're doing the horizontal motion, then shift right 6 units, and then, and it's right because it's a negative 6, so you're moving right 6 units, and then you're doing the vertical motion down 8 units. So that was like a little trickier. In function notation, it would be h of x is equal to f of negative parentheses x minus 6, and then minus, we'll close the parentheses, minus 8. And basically, you're reflecting over last year's notation, you're reflecting over the y-axis, and then you're translating 6 units to the right, and -8 down. Okay, we're going to skip to problem number 29, because that also has to do with transformations. If a quadratic function has a turning point of -3, 7, so a turning point and a vertex are the same thing, then where does the quadratic function g defined by, and they give you a function, have that turning point? So this is in function notation. We don't know what the function, well, we know it's a quadratic function, but they haven't written it as a quadratic function. This is in function notation. So this is just saying you're translating, there's no reflection, there's no negative. And again, if it's +4, that means you're moving 4 to the left and 5 up. Okay, so you're moving left 4 and 5 up. So if you have this original point, -3, 7, what does it become? It becomes -3 minus 4, because you're moving that point 4 spaces to the left, and then you're adding 5 spaces on, so that point becomes -7, 12, which is choice A. I hope this video is helpful, and I'll see you tomorrow.